Okay, this stuff is for section 5.4. I know that 5.4 is challenging because there's a lot of different things to do and a lot of different options. You know, you're just trying to get all of the different possible ways to solve these problems figured out. And so we're just going to go through 5 problems, I think 1, 2, 3, 4, 5 problems, and try to get you another glimpse of what it is we're trying to accomplish. First thing we do every time is look for common terms. What that means is we're going to look to see the numbers. Do they divide by anything? Well, 3 and 48 are both divisible by 3. And then when I go to take the y's, I always look at the smaller of the two exponents, or 3 or 4 or 5 exponents, however many y values there are. The most I can ever take is the smallest, and it looks like both of them have at least 3, so I'll take y to the third out. And I'll say what would be left over? Well, 3 divided by 3 is 1. Y to the fifth minus, so y to the fifth divided by y to the third is y squared. You can keep track of that too by subtracting or adding here. 3 plus 2 is 5. Okay. I'm going to have minus 48 divided by 3 is 16. And if you look, the 3 minus 3 means I won't have any y's here. This is good, but I also want to check inside this parenthesis and always ask the question, does this factor? Well, both of them are perfect squares, y squared and 16, and I have that subtraction. So 3y to the third. I would have y and y. This says the signs will be plus and minus. Square root of 16 is 4 and 4. Now, I'm done. So there's number 7. Again, first thing is take out common terms. Once that's done, check factoring, and you want to check for the factoring that you've done since day 1 first and see if that works out. If not, we go to other methods, but this looks pretty straightforward. So number 15, we would look to see if these divide evenly. They don't. 343 is only divisible by 7 and 8 is only divisible by 8, 2, and 4. But I also notice that these are, I'm adding something that's cubed to something else. Maybe these are perfect cubes. And so what I'm going to do is I'm going to, the goal I have in mind here is a cubed plus b cubed equals a plus b times a squared minus ab plus b squared. That's the formula from your book that I had you write down, and hopefully you're just realizing, okay, I see these perfect cubes. Well, I don't know if these are perfect cubes. Here's how I'm going to check. 8 raised to the 1/3, and in my calculator I might put parentheses around the 1/3 if I'm not sure. This should give me 2. And then 343 raised to the 1/3 should give me 7. What that means is that this is really 2 to the third c to the third plus 7 to the third. So now when I look at my a and b, my a is this stuff right here. A would be 2c because both of them are cubed in the first place. And b would be 7 because it's what's being cubed. I don't know, now my lines intersect, you can't tell which is which. But these are my values. That means I would have 2c plus 7 times 2c squared is 4c squared. You can keep track of that, 2c squared. All right, minus 2c times 7 is 14c plus b squared, that's 7 squared, is 49. Close my parenthesis, and I am done. Perfect. If there was something in common, that would have been the first thing pulled out, and it would be out here. But since there wasn't, this is my answer. Again, identifying the a and the b is the whole emphasis of this problem, okay? Then when we go to 21, it says for us to factor by grouping. To me, that means I need to slip a set of parentheses around the first 2 and around the last 2. And then look for what's common. In the first parenthesis, they share m squared. And I'd say, well, 3m to the third divided by m squared is 3m. And then m squared divided by m squared is 1. Plus, what do these share? They share a 3. So I pull out a 3. and I have 3m minus 1. Notice that the parentheses are the same. That has to happen or I've already made a mistake. So I will take the outside, m squared plus 3, and the inside, 3m minus 1. And there we go. Now I do want to check and make sure that nothing factors. Well, m squared plus 3 doesn't factor, so I am done. That's it. If it factored, I would go through the process and expand it more. 27. First step, once again, is to take out what's common. This is going to be a 2z. That gives me a 16z to the 4th minus 1. You might look inside of here and say, well, I don't think I can do anything here. But this is where we talk about the quadratic form. And the quadratic form means that we have similar types of problems to what we've done early on in the year. Well, I want to ask the question, this looks like if that was a 2, I could do difference of squares. And this was 16 x squared minus 1. It would factor as 4x plus 1 and 4x minus 1, because I just take the square roots. Well, a question I have here is, do I know the square root of z to the 4th? Well, actually I do, because remember, I want to say what times itself gives me this value. Well, z squared times z squared is z to the 4th. And so the square root of z to the 4th is actually z squared. So I can do exactly the same thing, I just have a different exponent. I have a higher exponent. So 2z times 4z squared, I get that from over here, minus 1, and 4z squared plus 1. Oh, but wait. I'm sitting here and I'm thinking this is my answer. But I go back, and this is one of the ones I wanted to go over because of this type of stuff. I look in here. Just like this was possible to factor, so is this. This is a difference of squares. So I'd have 2z times, and of course I have 4z squared plus 1. Because this is addition, this will not factor. If they were cubes, they would factor, like we did in the other problem. But here they're squared, so it won't factor. Over here, because it's subtraction, I can factor these, and I would have 2z plus 1 and 2z minus 1. Now I'm done. It's a lot of work, right? And yet it's not if we learn to recognize that I could take the square root of an even exponent by cutting it in half. All right. Then 35 is one where they tell us to solve. They actually want us to give the values of m. Now, I won't always have it work this way, but I'm expecting at most 3 answers. Well, I could try to say, is there anything common? But there's not. I could look for special patterns, but I don't see any. Usually when there's 4 pieces, I want to try grouping. So I'm going to split this by grouping, and I'm going to keep track of this negative sign there. Sorry, I got the hiccups. Keep track of that negative sign there so I don't lose anything. In here, when I say what do they have in common, I know it's an m squared times m plus 6. Out here, what do they have in common is a negative 4. And I always want to take that negative with us. Well, negative 4m divided by negative 4 is m. And negative 24 divided by negative 4 is positive 6. Good. See, I've got those duplicated parentheses. So m plus 6 times m squared minus 4 equals 0. I could set each of these parentheses equal to 0 and be done, start solving. Or, since this one still factors, it's a difference of squares, I have m plus 6 times m plus 2 times m minus 2 equals 0. To solve this, all I need to do is ask what makes each of these 0. I can either know from what we did earlier in the year that I'd be getting negative 6, negative 2, and 2, or I could say m plus 6 equals 0, m plus 2 equals 0, and m minus 2 equals 0, and solve each of them. by subtracting 6 or subtracting 2 or adding 2. Doing whatever's appropriate for the problem. But these are my 3 solutions. Alright, those are the problems I thought would be beneficial to you to see one more time. When you get to 42 through 47, just remember that it's any method goes, and so just kind of look for what feels right or what looks like similar problems to what we've already done. Good luck and have fun.